Hello everyone and welcome back. So in today's video we will continue on our Vex exercises, basically taking this thought-based approach or very Houdini based approach to create wood planks, and we will move into a Vex solution that is much faster to generate, and along the way we might learn a thing or two. So yeah, let's get into it. So in a fresh new scene, we will drop a geo container and we will start right away to creating an attribute wrangle. And this will be plot points. We will generate the points in here. I'm gonna press Z, change the shape, and also press C and change the color. So um, let's start by defining the width and the depth of our floor. I'm gonna make it 2 by 2, but you can change, you have the freedom to change the size. So float width, it will be a channel float called width, and we will do the same for the depth. So depth, and we will also need some other variables. We will need how many divisions we will have. So for the, or in this case, how many wood planks we will have per tile. So we will create an integer and call it planks per tile, which will be a channel integer called planks per tile. That's fine. And yeah, those are the parameters I want to create. So I'm gonna enable them and or create them and change the width and the depth to 2. And planks per tile we can set it to weight for now. So now we will need to do this. Usually we do this in a detail loop, so we can create a for loop and generate the points since we don't have any input geometry. But in this case I'm gonna change it to vertices, to numbers, so I can easily define the amounts, and this will be faster than a detail loop as I was testing. I believe it's because it's actually taking advantage of the compiling instead of using a detail and do a for loop inside, which it has to process in a linear way. That's my guess, but anyways, I found the numbers work faster. I'm gonna change the number count to 36, which will be the amount of divisions we will have on our floor. And right away, I'm gonna define the number of tiles, which should be equal to the number count. So I'm gonna set it to I at num_lm, so number of elements, which refers to this parameter in here. So also, I'm gonna define the tile ID, so tile it will be equal to I at lm_num. So each iteration of this count variable or parameter. Then what am I going to do in here? I'm going to start with the for loop that we will need. So this will loop 36 times, so to create the points. But inside we will also loop again to create the divisions of the wood planks. So for that, I'm going to create a for loop. So for, and we need to define the iterator, which will be, I will be naming point, and it will start at 0. Then I'm going to set the condition. So point minus smaller or equal to planks per tile. And then I'm just going to increase, so point plus plus to increase 1. Now let me see what makes sense to do in here. Let's open the curly brackets for the loop. And I need to define the position of the points for now. So I'm gonna start to define it outside the x position. So along the x, I'm gonna say float x pos, it will be equal to tile divided by the number of tiles. So float, gonna give it a space in here, float and tiles, and I'm gonna scale it by the width so it stretches to the end. And if we create, let's first create a vector pos, it will be equal to set, along the x will be x pos, and we can set y to 0 and z to 0 for now. So we have our pos, now we can just add point and we can actually say this is the main point, add point to the zeroing output, and pause, which is the position we want to create the point. So as you can see, it's generating the points, but in this case, so it should be generating 36 points. So it's actually generating more because we need to place them also along the Z. Now they are all on top of each other. So now let's work out. Let's also center these along the -1 to 1 range. So for that, I'm gonna just say xpos minus equals the width multiplied by 0.5 or divided by 2. And now it should center, as you can see. So now we need to figure out how to extend along the Z. So we need the Z position, and for that we're going to create in here. So float Z pos, it will be equal to the point divided by the planks per tile, and we will multiply it by the depth in this case because it's along the Z. So now if we take this and place it in the Z component, we should have the points along the Z. But as you can see, it's also not centered, so what we can do is to take the Z pos and subtract the depth divided by 2 or multiplied by 0.5, so divided by 2, not set depth. So now we have it in the center. And as you can see, we can increase the amount of divisions, and we can increase also the amount of planks per tile, and it's also adapting. It's like a resampling, let's say. Okay, now we need to define another point to create actually the geometry after. So we can connect this point to another point and this point to another one to create the square, the rectangular planks. But for now, we will randomize the position of the planks because right now they are all aligned and that's not the look I'm after. For that, I'm gonna create in here a random value to feed into the position of the points. So for that, I'm going in here, float rand that. It will be equal to the rand of the point plus tile. So we will use both seeds in here to create the necessary variation, and I'm gonna enable in here a seed. And then I also want to make it both positive and negative. So I'm gonna multiply this. So this is an extra one. I'm gonna multiply this by 2.0 and subtract 1 to make it both positive and negative. And then I'm going to multiply by an amplitude. So now if we take that random Z and we add it to the Z position, so Z pos plus equal rand Z. Now we need to create, of course, change the seed and do some amplitude. So as you can see, it's creating that random effect. We don't need to go too much, otherwise it will go over each other, so just a little bit. And then we can change also the seeds, let's say 5. But as you can see, it's also affecting the points on the extremities, so along the bounds of the depth. So what we can do is create an if statement in here, and this is what I came up with that seems to work. So if we do an if that pos is divisible by the depth or using modulo or is not equal to 0, we do the offset, otherwise we keep it the same. So let's see if that works, and it does. It snaps those points back. So now we just need to create the second point. So if you can visualize this, we will have a point in here, another one in here, then we have this one, and we need another one in here to create the quad. and we will keep doing the same for the others. So we need a second point actually. Let's do that next. So for the second point, it will actually be pretty easy. We just need to define in here a variable float w. It will be the width divided by the float of the end tiles. And then we can just say in here, let's say int second point, it will be equal to add point 0 on the x, and no, sorry, 0 is the input, and then we do a set, and along the x it will be pos.x plus the width of the blank, and then we do on the y 0.0, and along the z we just say pos.0, and this should do it. Let's see, should add a second point in there. As you can see, it's creating a second point in there, and this should work. Now we just need to set some detail attributes that we will end up using. So for that, I'm going in here and I'm just gonna set that detail attribute 0 input, and I'm gonna call it blank style, and I'm just gonna pass the blanks per tile variable. So that's fine. I'm gonna also need to pass an ID attribute for each blank. So after we do the adding of the points, we will, in this case, I'm gonna set a point attribute, and it will be call ID, and I'm gonna pass the point as main point and the tile. And I'm gonna do the same for the other point, so in this case, the second point. That's fine. Let's see if we have that. So call ID, we should have, let me increase the size of the points. We should have an ID for each tile, as you can see. I think this is working. Now let's pass to the creation of the polygons. So let's create another angle and generate polys. Gonna color it some green, and let's see how this one will work. So in this case, I'm gonna use detail to create the loop, and I'm gonna define some variables. So int total, it will be equal to the number of points, so numpt, and int points per call, it will be equal to the point attribute, so to the detail attribute that we created, which will be blanks blank style. Let's see if we have that attribute. So blank style 8, yeah, just a way to pass variables between nodes. So now we will generate the polygons. So for that, I'm gonna create a loop. So for define the initial tile, it will be equal to 0, and while tile is smaller equal to the total minus 4, since we want to create a quad, and then we will increase by 2 each tile, plus equals to 2. And the reason why we're doing that is because we want to create a polygon in here and then get this one, get the previous 2 and add more 2 and keep doing that. So we actually need 4 first and then 2 and add the last 2. I hope this makes sense. It will do in a bit if we actually create the polygons. So the points, we need first to define the points to create geometry. So int points array, it will be equal to an array of the tile, which is the current point, plus the tile plus 1, tile plus 3, since we need to do it in a clockwise manner, and tile plus 2, tile plus 2. I can give a space in here. So these are the points, and then we just need to create the prim. So int prim, it will be equal to add prim, to the first input, and we will create a poly, and the points will be the array. So let's see how that works. So obviously I'm doing something wrong in here, so add poly points, array tile plus 1, expecting 7, so int points array tile plus 1, tile, oh I need an extra comma in here. So as you can see, it's creating the points, it's creating the geometry, but it's also creating geometry from the bound to the second tile. As you can see this cross in here, so we need to fix that somehow. And for that, I'm gonna create in here some variables. So int offset, we need to skip the when we reach the end of each tile. So I'm gonna create an offset, and it will, oops, offset, it will be equal to 2 times points per call, which is this one in here, points per column. And I'm gonna create in here another variable called skip every n tiles, and it will be equal to the points per call plus 1 multiplied by 2. And if now we do in here an condition, so if tile minus offset modulo skip every n tiles is equal to 0, skip every n tiles, we just don't execute the code, so we just do a continue and continue. And as you can see, now we don't have that error anymore. So we are skipping the last tile, and now we should have our geometry. And just to finish this, we will set the prim attribute. So set prim attribute 0. I'm gonna call it prim ID, and it will be on the prim that we generated, and the value will be the tile. And if now we look at that, we have a single ID for each blank. So yeah, hopefully that makes sense. It still confuses me a bit the way we are doing this offset and skipping end tiles, but basically we are avoiding connecting the end of this tile to the next one. So in the next part we will do the random transformations on this geometry. Okay, now let's do the random transformations, and it will be easier if we actually do it with packed primitives. So I'm gonna pack this into single points, and I'm gonna say name attribute and use the prim ID. And now we should have 288 points like we had on the prims previously. And I'm just gonna make sure I do wire over packed prims so we can actually see this. And now let's do a point wrangle. So this one will be called rand transform or transforms. I'm gonna set in here color, that's fine. And now we will define first a seed so we can actually change the result. I like to use integers. Then we will also do random orientation and random scaling. So let's define those random variables. So float angle, it will be equal to radians, not radians, and we will use a channel float called max angle. So this is the maximum it will rotate, and we will multiply this by a random of the primnum. So primnum, and we will use the seed, and we need to put that between brackets and then multiply it. So and then we we multiply that by 2.0 minus 1 to make a zero centered offset, and we close the bracket. So in here we actually need to put this expression between brackets, so then it does the scaling properly. So now we need another one for the scale, so float scale, it will be equal to channel float called max scale, and I also want to scale it up and down, so randomly, so we can actually do the same in here. So rand of the primnum plus seed and do the zero centered offset. Now we need to load the matrix of the back transform, so matrix 3, it will be named transform, and I'm gonna load the prim, intrinsic, and it's called transform, and I'm gonna use the primnum. That's our main matrix. Then we will create a new one, so matrix 3 m will be equal to ident, so we will initialize it. Then we will do the scaling, so scale of this matrix that we just created, and we can just do a vector of 1.0 plus scale. And then we do the rotation, so rotate m, and it can be a vector of the angle. And we also need to pass the order of the axis. So in this case, I'm gonna set it to 1. It will be the same as x, y, z. So now we just need to set the prim intrinsic. So set prim intrinsic, and it will be 0. The incoming geometry, the transform attribute, the primnum, and the transformation, it will be the initial matrix multiplied by the matrix we just created. This does nothing because we need to change the seed and the max angle. So in this case, I'm gonna set it, let's say 10, and the max scale. So I'm clearly doing something wrong in here. So let me check that. Oh, I believe it's because in here is not named properly, so transform. Now it should work. So we can change the seed and we can increase the max angle, let's say to 1, and play also with the scale. So let's keep it pretty low. Let's now unpack, and we should have everything back. So in this case, I'm doing random, using the same angle for all the axes on the rotate function. That might give us not so pleasing results, so you can probably play with different angles for each axis instead of passing here as a vector the angle, or just do it in one axis. So let's say set 0 angle 0, so it just rotates around y, but in this case I'm doing like that. You can totally change it. So I'm gonna set this just to 1. That's fine. We can play with the max scale, so it will scale up or down depending on the seed. And yeah, you can pick a value that you like. I'm gonna keep it like this. So yeah, guys, a lot of work done, and hopefully you learned and picked up a few tips. Nothing too exciting, but we generated these points, and as always we can come back, change the amount of divisions, change the amount of blanks, as you can see, change the randomness so we can keep it normal or randomize it. Don't go overboard, otherwise it will get problems. We can play with the seeds, we can change the width and the depth, and yeah, also control over the randomization. So let me know in the comments if you learned something new, and as always you can grab the files on my Patreon alongside with exclusive tutorials, and also make sure to check out my courses in there, which are pretty cheap. And yeah, thank you for watching, and I'll see you next time.